Okay, so I'm going to put a couple video solutions to the problem sets up here so people can refer to these at home if they need to. I'm just going to go through the assignments problem by problem and just talk through them and provide answers. So here it goes. I'm in the Honors Algebra 2 class. Let's see, this is 1.1.1 Review 1, so this is just Module 1, Section 1, or Lesson 1. Okay, so we want to write the domain of the function as an inequality. When we look at this function on the board, we can see that it's unrestricted. We're seeing a small snapshot of the function, but if we were to expand the screen out to zoom out infinitely far, we'd see that the function just continues on to the left and up and to the right and down forever. And so the domain is unrestricted. And so our answer is going to be, being as we want to write this as an inequality, remember that the way that we write an unrestricted domain, that involves x's. It's a set of all x values. And so we would write it like this. We'd say that x is greater than negative infinity, which is all negative values, and less than positive infinity. Okay. This one, we're looking at writing the domain of this restricted function. So it's, we do have endpoints here. And so we're looking at the set of all x values. So we just want to see what are the x values that can be input to make this graph. In terms of, sometimes we talk about ants in our class, and this would mean that what are the x values that an ant could walk on from the left endpoint to the right endpoint. Well, he'd start off with an x value of -9 and end up with an x value of +9. And because those endpoints are filled in, we would include those in our domain. And we want to write this using interval notation. And so remember, that's where we're going to provide only the left and right endpoints separated by a comma. Remember, they have to be in increasing order, just like a number line. So we'd get -9, 9. And then what types of brackets would we use? Parentheses or brackets? Well, because we're including the endpoints, we would use square brackets. Okay. This is going to be an example just like the first example where the function's unrestricted. So writing that as an inequality, we're going to get that answer again. Okay, another restricted domain. This time the x values run from -10, including -10, because the endpoint is shaded, to, looks like, -5. In interval notation, what did I say, -10, -5, yeah. Okay, so the range of this function, using interval notation. So this time we can see that the function is, as an ant walks down from the left, he's walking down from infinitely high. He's coming from a y value of infinity, walking down, 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 and he walks along, and it looks like his y value is approaching a value of 1. Now, because this is an asymptote, that means that he's never quite going to get there, but he's going to get closer and closer and closer. So that tells us then that the y values that are output for this function would be all of the y values above but not including 1. So using interval notation then, our bottom limit, which has to go on the left because we go from decreasing to increasing, smaller values on the left, bigger values on the right. Our left value is 1. And our right value is unrestricted, meaning the top value in terms of y. Our upper limit is, there is none. So infinity. As an inequality, this would read y is greater than 1. That's it. We don't have to say anything else because there's only a bottom limit on this. Write the range of the function as an inequality. Okay, so this time let's look at what the ant does when he walks this function. He starts off standing on an x value of -7 and a y value of 0. He walks downward to his bottommost y value, his lowest y value, which is -7. He walks up to his highest y value, which is +7. And then he walks down, approaches, but doesn't ever get to x equals 4. We really don't care about the x values. It's asking for the range. All we want is the range of y values. So his smallest value is -7 and his biggest value is +7. As an inequality, and he could actually have those values, right? He could stand on a y value of -7 or +7. In other words, the function really does have those values. So I would need to use square brackets, inequality, sorry. So we would say then that y is greater than or equal to -7 and less than or equal to +7. Now notice once again when we write out compound inequalities representing domains or ranges that the inequality symbols always open from left to right, from smaller to greater. Like we said, it has to be like a number line. Range of this function, very similar problem. The bottommost y value is -10, the topmost is 0. Using interval notation then, we would use closed brackets, square brackets, and go from -10 to 0. Range of this function, it looks like here we're actually not including -4 because those endpoints are both open. So therefore we're not going to include that. We're just going to say that y is greater than -4. But at the top of the y values, our largest y value that the function actually takes, or that the ant could step on, is +2. So we're going to have to say it's less than or equal to +2. Okay, range of this function is unrestricted. It goes, on the left it goes down to -infinity. On the right it goes up to +infinity. So using interval notation, we'd have to use rounded brackets or parentheses because we're not including the endpoints, and we would run from -infinity on up to +infinity. And last one, range of this function, looks like this function it does have a limited range. It has a topmost or largest value, but goes down forever. So there is no restriction there's no lower limit, but there is an upper limit. So using interval notation then, we would have to write this one with different types of brackets on each endpoint. At the bottom, we'd have to use parentheses, and so the way I do this in Moodle is I'll just, on the keyboard, I'll hit Shift-9 to open up a set of parentheses, and I'm going to go from -infinity on the lower end to comma. On the upper end, it's going to be y equals 1. You can see right there that the topmost y value is 1. And I'm going to write a right bracket, which is 2 keys to the right of the P. And then it'll change that rounded parentheses into a bracket. And thus ends our first video solution.